In this tutorial, I'll discuss controlling IR devices, IR as a control method, the similarities between IR and relay control applications. I'll draw a comparison between IR channels and relay channels, and explain how device IR functions are arranged into independent IR channels in the IR files. If you want to do a quick review of what's been covered previously about IR control, you may go back and watch these tutorials from the core curriculum. In parts 6 and 7 of Control Essentials in the core curriculum, you are introduced to relay control and IR control. During that video, you may have noticed similarities between the two control methods. You may also want to revisit part 2, wire and signal types of cabling essentials. The output IR port in the next example is the one which resides physically on the Netlings controller itself. In fact, the output IR port could be that on the controller or some other hardware interface, for example, an ICS LAN interface such as this EXB IRS4, or on the DX-Link transmitters and receivers. Let's take a moment and plug some device numbers into this diagram. Did you get that or something similar? If not, don't worry. This will become clearer as you progress. If you're completely lost at this point, you may want to review Lesson 1 in this programming course, or online in the various product hardware reference manuals. For example, the port assignments for the NX2200 shown can be found in the hardware reference manual NX Series Netlings NX Integrated Controllers. For simplification, I'll concentrate on the button event from a touch panel and the IR port on the integrated controller. On the surface, this is how IR control works in an AMX control system. A button on the touch panel is pushed. The push event is detected at the master controller, and the master instructs the DVD player to play. As an audio-visual programmer, it is vitally important to understand all the aspects of the hardware and the processes before you start punching in the ones and zeros. So let's take a deeper look at the sequential logic so that we have a better picture of what has to be done in the background to make this work. For example, when the play button 1 is pressed on port 2 of the touch panel, in the source code, port 2 of the touch panel is defined as DVTP DVD or DevTP DVD. The master gets a message that port 2 channel 1 has been pressed and looks under the event section of the compiled code for the corresponding event statement and executes it. In other words, when the button channel gets pushed, the master should pulse DVDVD channel 1. Under the defined device section of the source code, port 11 on the master is defined as DVD. So the code is the statement that instructs port 11 on the master to pulse channel 1 on and then off. Port 11 has an IR file mapped to it. Channel 1 refers to the IR pulse for play for a Tascam DVD player. This IR pulse fires from the IR emitter, which causes the DVD player to play. In Netlings programming, IR control is similar to relay control, and so we can build on what you have already learned. In exercise 1, relays were controlled by manipulating their corresponding channels using the on, off, pulse, and min2 keywords. For example, to pulse relay number 1, the following statement was used: pulse DV relay, 1. Assuming that it is normally open relay, Netlings interprets the statement and using the default configuration closes, waits a while, and opens the physical relay contact for relay number 1 of the controller. For IR control, the code looks very similar. Pulse DVIR device, 1, and produces a similar result. That is to say, IR channel 1 will turn on, wait, and then off following a predefined period for the time as determined by the last set pulse time statement that preceded it. The IR control statements look similar to the relay control statements, but instead of manipulating a physical independent relay associated with each channel, Netlings instead fires off the specific IR function that has been stored in the memory location for a specific IR port that corresponds to the assigned channel of the saved IR file. The only difference is that while relay channels directly manipulate the states of associated relays, IR channels tell Netlings which corresponding IR function stored in the IR file must be transmitted out to the IR control device. So for any IR control device, like a Blu-ray player or set-top box, all of the discrete IR commands for each button on the handheld remote must first be captured and stored in an IR file. Each function is saved and allocated a unique IR channel. The play function gets assigned to channel 1, stop assigned to channel 2, pause assigned to channel 3, and so on until all the remote functions have been saved and assigned a corresponding channel number. The IR file is then uploaded to the controller ready for action. As discussed earlier in the tutorial, each IR file must be uploaded and associated or mapped directly to the IR port on the controller that is physically controlling its corresponding device. Remember the DPS triplet? If the IR device to be controlled is a DVD player connected to IR port 1 on a DVX2255, then the device identifier will look something like this. DV-DVD equals 500111 0. A subsequent IR controlled device, for example a set-top box, could then be connected to IR port 2. The device identifier for port 2 would then be DV-STB equals 5001 12 0, and so forth. 2 points to note with regards to the IR file. There is no IR file loaded into the controller. Then the IR channel will not in fact respond to the IR command from Netlinks. The command will be issued but nothing will happen, and the activity LED will reflect that by not lighting up when the IR command is executed. This is different from relay control, where the relay and corresponding LED indicator will always respond when an instruction is given. In a second scenario, if the IR file is loaded but the assigned IR channel in the IR file is empty, it similarly will not fire and the associated LED indicator will not light up. Up to this point, I've been using the pulse keyword in the IR command statements. IR functions will continue to fire repeatedly for as long as the IR channel is on. Just like on most handheld remotes, if you continue holding the volume up button for an example, the volume will continue ramping up until the button on the remote is released. A limitation of the pulse keyword is that it only momentarily turns the channel on for a predefined time before it turns the channel off. But what if you want the IR channel to stay on longer, or for as long as you hold the button? For this purpose exactly, the to keyword is available in Netlinks and can be associated with IR control. Using the to keyword produces the same result as pressing and holding the button on the handheld remote. By holding the associated IR channel high, for as long as the control button is held, the IR code will continue to fire repeatedly until the user releases the control button and the IR channel is reset. The source code in the example shown is interpreted as follows. When the DVD volume up button on the touch panel is pressed, the DVD volume up IR channel is set high and held high for as long as the user has their finger on the DVD volume up button on the touch panel. We have previously learned that the default pulse time in a Netlinks controller is half a second. But why does that matter? A half second is not appropriate for all IR functions. Because IR codes vary, and vary in length or time specifically, a 0.5 second pulse may be too long for some device codes, and the result would be multiple codes firing off when not warranted. Similar to when pressing a PTZ button on a remote, sometimes multiple codes fire off, and instead of getting the camera to shift once, it shifts 2 or 3 times, for example. For these reasons, it is common practice to set the pulse time before each pulse statement. This will ensure that the desired pulse time for a specific device is always predetermined correctly. Of course, as I have shown, we can remove the pulse statement altogether and instead use to